Hello everyone. Today we'll start with class 12th chapter probability lecture number 6. As I told you in the previous lecture that we are going to learn about random variable, probability distribution, mean and variance of the probability distribution. So let us start with the random variable. Random variable, here is the definition. It says let S or U be the sample space associated with the random experiment. A real valued function x. Real valued function x means x will have real values defined on the sample space, that is x defined on the function this is u, which is the sample space, to r is any real number. It is known as random variable. For example, suppose I define x as number of heads, right, and the experiment that I am performing is suppose of tossing a coin 3 times. Okay, tossing a coin thrice. Now, when we throw a coin 3 times, the possible outcomes are head, 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 tail, head, tail, tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, tail, and tail, tail, tail. So these are the 8 possible outcomes that we have when we throw or we toss a coin 3 times. Now what is x defined as here? X is a random variable. Random, why? Because it is associated to the random experiment. And what is it showing? Number of heads. So x can take the values. I see here 3 number of heads are there, right? And then 2 numbers of heads are there. Here it is only 1 head, and then in this I see there is no head, that means 0. So x can take the values as 0, 1, 2 and 3. These are the values that this random variable can take up. So this is how we define a random variable in probability. It is defined on any random experiment that we are performing, and it will show number of heads, number of tails as according to this particular example. Now we will move to the probability distribution. Here is the probability distribution definition. In this it is saying if a random variable is there and it is taking the values as x1, x2, xn, that means it is, as we considered in the previous example, the values for the random variable were 0, 1, 2, 3. So likewise they're defining in general way x1 to xn with respective probabilities as p1 to pn. Then the probability distribution is defined as like this. We write values of x, we write values corresponding to that particular random variable probabilities. Then all the probabilities, all the random variable values are written. This we write actually in a table, and this is known as probability distribution of x. How do we do it? Let us see. In tossing a coin 3 times, tossing a coin 3 times, the number of outcomes were 8, which were head, head, head. I am again writing them: head, tail, head. So these are the 8 outcomes that I have written when we get or after tossing a coin 3 times. Now just to see what was x defined as number of heads. So now how to make the probability distribution table? I'll show you that. What we have to do is we have to draw one table in our notebooks. Okay, in the notebooks we draw it and we form x and p of x. Okay, so x here, p of x here. Now what are the values of x? 0, there can be 0 number of head, there can be 1 head, there can be 2 heads, there can be 3 heads. Okay, now probability of getting no head. probability of x equals 0. This is the representation. That means no head. No head, there is only one case, which is this is tail, tail, tail. So which is tail, tail, tail. That means 1 over out of how many? 8 outcomes. Now probability of x equals 1. That means getting one head, exactly one head. For one head, how many outcomes do we have? 1, 2, 3. 3 outcomes out of 8 outcomes. Probability of getting two heads. Let us see two heads in how many? This is 1, 2, 3. As you can see, for two heads we have again 3 outcomes. Okay, now for 3 heads there is only one, so it will be 1 by 8. So this table now is known as probability distribution chart or probability distribution table for the random variable x. X denotes number of heads, p is denoting the probability of that particular random variable for different values like 0, 1, 2, 3. I hope this is clear. Probability distribution, how to create. Let us move to the next concept, which is mathematical expectation or mean. Whenever it is written in the question, find out the expectation, find out the expected value, find out the mean. They all are synonyms to each other. They mean the same thing. How mean is defined for the probability distribution? Just to see. If x is a random variable which assumes values from x1 to xn with respective probabilities from p1 to pn, then the mean x of the random variable, which is capital X, is defined as E of x. This is the representation for mean, equals p1 x1, p2 x2, pn xn in journal sigma pi xi, where I is from 1 to n. Now as I have shown you the table in the previous example, just to see, we formed this table. I'll just write this table again. Okay, so I was forming a table. Let us write that table again and make it again. So in this, I'll be just drawing out the rows and columns. Here we will write x and px, x as equal to 0, as 1, as 2 and 3. Okay, now just to see, here x and here p of x. So what were the values that we were getting? 0, 1, 2, 3, where x was number of heads. So it was 1 by 8, 3 by 8, 3 by 8, 3 by 8. One more thing, in questions they will be giving you probability distributions and you have to identify whether this can be a probability distribution or not. In that case, you have to add all the probabilities. As here, if we add all the probabilities, we get, so we will be adding, last one was 1 by 8, not 3 by 8. So when we add them, see, we get 8 as the LCM, 8 by 8. The total probability should always be 1 in this case. So this is how we verify or identify whether this is a probability distribution or not. Now, how to find the mean of it? Suppose I have to find the mean of it, I will represent it E of x. Okay, how to find it? Xi into pi. I have to multiply the probability with the random variable value. So multiply 0 into 1 by 8, 0, plus 1 into 3 by 8, 3 by 8, plus 2 into 3 by 8, 6 by 8, plus 3 into 1 by 8, 3 by 8. Take the LCM, 6 and 6, it will be 12. 3 by 2 is the answer. 3 by 2 means 1.5. So this is the value for mean that we have. Clear? This is how we are going to find out mean. The first thing was to find random variable values. The second thing, find the corresponding probabilities. And the third thing, to make the table and then find the expectation or the mean or expected value. This is known as mean. Now, the next point, as you can read here, is the variance on the probability distribution is calculated as, this is the representation for it. How we calculate it? Sigma x, we calculate it as sigma, or this is not sigma actually, this is the capital E. right? Don't misunderstand it. Capital E of x square minus the mean that we were calculating, its square. So as you can see in the formula, capital E into this x square, what does this mean? As we are calculating mean here, okay, let us use a different sheet to find it out. Okay, let us draw the table again. So in the table, we were having different values. So we'll write all the probabilities here. Uh, yeah. Okay, let us write the things in it. So we had x, we had p of x. Okay, I'm doing this for variance. 0, 1, 2, 3. The probabilities were 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Now just to see, variance formula is variance of x expected of x square minus the mean that we calculated, its whole square. This is the formula. Now how do we calculate this? For this we have to do square of the random variable values. Do that. Square of x, 0 will be 0, 1 will be 1, 2 square will be 4, 3 square will be 9. Now we have to multiply the probabilities with the value of x square. 0 into 1 by 8 is 0, plus 1 into 3 by 8, 3 by 8, plus 4 into 3 by 8, 12 by 8, plus 9 into 1 by 8, yes, 9 by 8. So this is this value that we are writing. We have to subtract the value of mean. As I can show you, we calculated mean as 1.5. 3 by 2, 1.5. Now we just have to solve it and write the value for variance. I think that everybody can do. So this is how we are going to calculate a variance, mean, random variable, probability distribution. So this is all for random variable and probability distribution. Now based on these things, you can actually do from exercise question number 1 to 10 of exercise 13.4. Try these questions. In the next lecture, I am going to discuss some questions from 1 to 10 and more questions from the same exercise. Thank you. That's all for this.